Different MPLS modes. In this video, I'm going to talk about different MPLS modes. For example, label distribution mode and label retention mode, and finally LSP control mode. I explained about label distribution mode in the previous videos, but in this video, first I review the label distribution mode, and after that I will explain label retention mode and LSP control mode. Maybe you remember that we have label distribution mode in two forms in the MPLS. The first is Downstream On Demand or DOD label distribution mode, and the second is the Unsolicited Downstream or UD label distribution mode. Let's review these topics first, and then we can go to the other MPLS modes. For example, we have these networks R1, R2, and then R3. Okay. Also, maybe R1 connected to other router, for example, R4, and R4 also connected to the R2. Okay, this is our networks, and then R3 connected to the net A. You know that by default every router should generate a label for net A with LDP. For example, maybe these routers use this label, uses this label in R3. In R3 here, I write the labels. In R1, first I start with R1. For net A, we have a local label, local, that is 100. Okay, and then again in R2, R3, and R4. Here, very good. R2, then R3, then R4. This is local label binding. In R2, maybe it chooses 200, in R3 300, and in R4 400. You know that every router should advertise its label to its peers. If you enable MPLS on all interfaces in this scenario, we have LDP neighborship between R1, R2, and also between R2 and R4, and again between R1 and R4, and also between R2 and R4. These are our LDP neighborship or LDP peers. In this time, we can experience two types of label distribution. The first type is Downstream On Demand or DOD. In the DOD or Downstream On Demand, the labels doesn't advertise automatically. For example, if R1 chooses R2 as next hop for net A, because for example we have here OSPF as routing protocol, and OSPF says to R1 that the best next hop to net A is R2, okay, because the lowest metric, for example, because R1 learn from OSPF that the next hop for net A is R2, it sends a request to the R2. This is a request, and wants from the R2 that advertise to R1 a label. Okay, here R2 receives a request for label of net A and advertise label, for example 100, its label 200 to the R1, and then R1 can use this label to forwarding the packet to the R2. This is Downstream On Demand, and this means that R1 should request from downstream router for net A to send a label for that network to him. Because of that, in this fashion, in this model of label distribution mode, in R1 only we have one label for net A from remote routers. For example, in R1 we have only one router, and that is the label received from R2. The 200 from R2, LSR R2, and that the label is 200, for example. Okay, the first method is downstream on demand, and this means that we should request to downstream routers, and after our demand it sends to me a label. Because of that, only one label from remote routers exists in the LIB, and we can use it. The first method. But if you remember, we didn't use this method in our scenarios. Why? Because we don't use downstream on demand on frame mode MPLS. Okay, we use unsolicited downstream UD label distribution mode. This means that without the need to the solicitation from the R2 or other routers, all of our peers should send their labels, their local labels to us. For example, in the second method, in the unsolicited downstream, R2 sends to R1 its label, its local label for net A, that is 200. And also R4 should send its label to R1, that is 400. And R1 now has two remote label or many remote label for a network. Let's say R4, for example, 400. And maybe it uses only once one of these labels. For example, in use label is the label received from the next of 200. But it receives more labels, and it receives labels from every peer. The second method is better for convergence, because if the link between R1 and R2 goes to down state, immediately R1 can use the labels received from R4, because the new next stop is R4, and can choose R4 as next stop with OSPF, and then R1 had the label from R4 and can use this pass. And this is the second method, is the best method for convergence, but also it has a negative impact, and that is the more memory usage, more CPU usage in R1. But the first method, downstream on demand, has has less overhead, less resource overhead, for example, CPU and memory overhead, but the convergence time may be more. Okay, let's review the topic. Label distribution mode. The MPLS architecture has two modes to distribute label binding. First, downstream on demand or DoD label distribution mode. Second, unsolicited downstream or UD label distribution mode. In the DoD model, the first method, each LSR requests its next stop. R1 requests its next stop, that is R2, that is downstream LSR, on an LSP. LSP means for example, net A. A label binding for that FEC requested, and then each LSR receives one binding per FEC, per destination, only from its downstream LSR on that FEC. The downstream LSR is the next stop router indicated by the IP routing table and by usage of, for example, routing protocol. In the UD mode, the second mode, each LSR distributes a binding to its adjacent LSR or to its neighbor LSRs without those LSRs requesting a label. In the UD mode, an LSR receives a remote label binding from each adjacent LSR. You can see this method. And then in the case of DoD, the lib or LIB choose only one remote binding, whereas in the case of UD, you are likely to see more than one. Okay? The label distribution mode used depends on the interface and the implementation. You know that we can implement MPLS in two modes. First, frame mode, that is used for every network, every data link except the ATM, and then cell mode, that we can use this mode only in ATM networks. Okay,